we are now live. So I'll just give a couple of seconds for people to join the stream and get your audio sorted out. Welcome to the Festival tomorrow. If this is your first session, where have you been? This is the end of day 3, but glad you could join us. And if you've been going to lots of the shows, I hope you've had a good time. And thank you for kind of making it to this one, this extra one we've added in. So well done for spotting it. And hopefully you've been enjoying the exhibitor booths too. So we're really, really fortunate to be able to have this and be able to add it. And it's one of those joys of being in Swindon, that we've got places like the UK Space Agency right here on our doorstep. If you have some questions, which we're going to watch a short video, but then I want questions for Sue, she's ready to answer them. I just want to first, before we do anything else, just introduce Sue Horne, who's the head of space exploration at the UK Space Agency. Is that correct? Have I got it right?
Yes, that's correct. Good afternoon.
Good afternoon. So thank you for joining us. I think we're really, really privileged to be able to have you here. I think you've just been non-stop working for the last week, with stress within that. Is that about right?
Yes, it's been a very busy week. We've had the astronaut announcement and Perseverance launch, and we've had a big ESA meeting as well. So it's been a really hectic week.
I used to work with Sue, but I escaped. So I've avoided this trauma of this amount of work. I could just get to play for a living now. So I'm going to quickly show a little video that's been put together about the mission and the UK's part in it before we get questions, because it's all a branded NASA mission, but actually these things are generally big international collaborations, and the UK is right at the forefront of a lot of the technology. So we'll just play this video.
So Mars 2020 Perseverance rover is landing today in UK time at about 8:30 in the evening.
This mission is totally exciting. Scientists like myself are really excited about getting samples back to Earth because we can do so much more analysis.
Jezero Crater was one of 4 shortlisted areas that could have been chosen for the Mars 2020 landing, and Jezero Crater was picked on the basis of the fact that it has some very interesting geology.
I was invited to create this artwork for the UK Space Agency to sort of inspire the public about Mars and all the amazing science that's going on to find out more about it.
So our understanding of Mars is relatively limited compared to our understanding of the Earth, but we do have a lot of information on Earth rocks. And so if we assume that conditions on Mars in its early history were the same as conditions on Earth in its early history, we can use Earth's record to guide us in sample selection on Mars.
You'd be surprised how much information and how much data can be extracted from just a few grams of rock.
You know, it's our responsibility to collect these samples. These are going to be the most expensive samples ever collected.
And so we want to prepare as best we can for future generations that are going to analyse those samples and try and work out some of the biggest questions in the solar system currently.
It's the most complicated mission that NASA has ever sent to the Red Planet.
Bringing samples back from Mars is an international venture, not only because it's quite difficult to do, but because the samples are the property of humanity.
Rover operations are very, very complicated. They involve a lot of people, scientists and engineers interacting online.
When Perseverance lands today, we're going to have 7 minutes of terror when we don't get any signal back from the spacecraft as it's hurtling through Mars's atmosphere. We've got every confidence, though, in our colleagues at NASA that they've designed everything as safely and securely so that the rover lands safely on Mars.
I think they know exactly what they're doing. They've got it completely controlled. We have a whole set of systems trying to work out exactly how Perseverance is going to land.
The samples that the Mars 2020 rover is going to collect, we think might come back to Earth in about 2031. And so if you're watching this now as a young person, there is a very good chance that in 10 years or 15 years or 20 years, maybe if you studied geology or chemistry or biology, gone to university, become an expert, that you could well be studying those rocks yourself.
You could be one of the researchers as a PhD student or a postdoctoral researcher who actually gets to analyse those rocks. It's not going to be me. It's going to be one of you doing that, and I think that's hugely exciting.
that actually, that made the hair stand up on the back of my neck. It's incredibly emotional for me, and I haven't been working on it. What's it like for you to be kind of looking at it this side of landing? I know the mission still has a lot left to do.
Oh, it's really exciting now. I'm just a bag of nerves until I know it's landed safely. I've been involved in missions that haven't landed successfully. I've actually been at launches where the rocket has blown up. So I am always really nervous, and you put so much energy into the missions. I have been working on Mars sample return, which is this is the first stage, since about 2007.
Wow. I don't think people quite realize how long these missions take, just from when they're first proposed and getting agreed and funding. And then generally when you agree to do the mission, you literally have no idea how you're going to do it, do you, in terms of the technology? I mean, what's that process like?
And that's the first stage. They usually have a call for ideas, and people can put their ideas in, and they do some initial studies that look at the feasibility and what technology needs to be developed. And if at that point, if you think it's feasible, it can go forward. But it's a very strong competition of what missions get selected. There's scientists all over the world putting in ideas of what might be next.
So, I mean, my youngest son was born in 2008. This mission has been going on since before he was born, which is shocking. Yeah.
Well, I was involved in a mission called Rosetta, and I started working on that mission when I was pregnant, and it actually arrived at the Comet, and my son had just finished his degree. We worked out that if he had an interest in that area of science, he could actually be doing the research on the data.
So there's moments when we're all kind of watching it on TV, and we'll talk about how that feels for kind of us kind of civilians. But having put a huge chunk of your life into it, that kind of will it land, won't it? It's kind of exciting for us, but for you, it must be utterly terrifying.
Yeah, it is. You see some of the scientists' photographs of their instruments that they take before they were integrated on the spacecraft, and it's like those baby photographs on a piece of towel, or it's that sort of level of commitment.
Yeah, and I think the other thing, as I was watching it on Thursday night, and I think a lot of people in the chat watched it, I think because it looks very kind of looks very space agey. NASA are all very slick, so it looks quite Hollywood, and so you think there's a bit of a fake drama and a fake peril, but landing it isn't as easy as it kind of sounds. You're kind of saying it's a great story you were telling me earlier about your press releases. Can you tell that?
Oh, I think so. I was told this. I don't know how true it was, but when they landed the Curiosity mission, and that was the first time they tested this landing technology, the NASA people at the press conference actually had the briefing for a failed landing on the top, because they thought that was the most likely possibility.
That's awful. That's awful. So I'm going to ask you just one or two very quick questions, and then I want to pass it on to the questions from the attendees, because this is really about them asking questions, not me. But it's just such a fascinating topic. But because we did all see it branded NASA, what exactly was the UK's involvement? Was it big? Was it small? And how does it fit into the space industry? Generally in the UK. Okay,
so our major contribution comes later in the Mars sample return sequence of missions. But on this, we have been heavily involved in the design of Mars sample return, which is 3 missions together in sequence. So Perseverance is the first one. It will collect the samples and put them seal them in tubes, and then drop them on the surface of Mars. In 2026, we'll send an ascent vehicle, which is the rocket that will take the samples from the surface of Mars into orbit, and a fetch rover. So that lands with the ascent vehicle, and that will go and find these tubes that have been deposited on Mars' surface and take them back to the ascent vehicle. That vehicle will be built in the UK at Airbus Stevenage. They then get loaded into the rocket, shot into orbit around Mars, and the samples are now contained in a container that's about the size of a basketball. And that is orbiting Mars. And then you send another spacecraft to catch that basketball orbiting Mars and bring it back to Earth. And that they will come back to Earth in the early 2030s. So we've been involved in the mission architecture of how you do this. We've been heavily involved in how you protect the samples from contamination on Earth. Our scientists have been involved with NASA working out which science instruments should be on Perseverance to actually select which samples are going to be taken and put in the tubes. And now we have got scientists involved in the science operations, and they will decide when they're looking around the Mars surface which samples to take. And I know our first scientist is now working on the operations, and he started work at 3 o'clock in the morning on Friday. Yeah, and they do 12 hours, roughly 12-hour shifts, but they work on Mars days, which are 24 hours and 40 minutes, roughly. So it doesn't do your body clock a lot of good. No. And then there was a UK company that provided the material for the parachutes, and Teledyne E2V provided some of the sensors for the cameras and the Sherlock instrument.
I'm going to have to come back to what is the Sherlock instrument. But the questions are flying in now. We've got over 200 people kind of watching now, and the Q&As are starting to fly in. So I'll try and get through them. Essentially, I'll go them in order. So the first one I've got at the top. So it is kind of really to do with the rovers and how are they repaired if they malfunction on Mars?
You don't repair them. You can't repair them. So
pretty straightforward then.
You're basically stuffed. So that's why they go through extreme regime of testing before we send them. The materials are tested. They've gone through life tests of operations of the joints and the wheels and things. And then once the rovers are integrated, you test them again. So it's test, test, and test. Now, if it's a software problem or something like that, they can upload new software. But if it's a mechanical thing, then you really have a problem. Although I think some of the rovers have been managing to get round on 3 wheels type things when wheels have jammed up.
Right. But yeah, if they're completely, if they're broken, they're broken at that point, isn't it?
Yeah.
Unless Matt Damon happens to wander past. Can I ask, here's a question. So 2007 you started, this project started, but when did the Mars Perseverance rover actually leave Earth? How long was it in travel?
That was 7 months ago. So every 2 years, the orbits of Earth and Mars are in a suitable position that it only takes 6-7 months to travel between the two planets. So that happens every 2 years, and you've got a window of about 3 weeks each time. So that's why you get these cluster of spacecraft all at the same time. So we've had the United Arab Emirates orbiter arrived last week, the Chinese Tianmen orbiter with a lander arrived last week as well, and that will release its lander, I believe, in May. And then we got Perseverance this week.
Okay, yeah, that makes sense, because it's like, yeah, I'm not going to make the bus comparison, but it does feel a little bit like that, doesn't it? So again, this thing about space missions, it just sounds very, very glamorous, and we're used to kind of hearing these kind of sexy American NASA voices, and space always seems quite far off in terms of a job. Very few people grow up thinking I could work in the space industry, but and a lot of people don't realise how much UK space industry there is. How did you get into the job you're doing? And for kind of kids growing up in Swindon, going, actually, could I work in the space industry in the UK? What's your answer?
Right, I got into my job by pure accident. So I would say, do the science subjects that you enjoy. You always excel best if you're enjoying it, and you need to go do a degree. If you want to be an astronaut, you need to have done a PhD, and you need to have studied a language. So although you may specialise in science, don't give up on the language if you want to be an astronaut. And it's a very international. We're working across with Europe with scientists. We of course we work with NASA. We're beginning to work with the Chinese and India. So it's an international. Being able to work as a team is a really important thing in the space industry.
Is the jobs market growing then in the UK for space?
Jobs market is growing. And I'm trying to remember my numbers. I think it's about 30,000 people in the space industry. That's upstream and downstream. Upstream is the making of the spacecraft. Downstream is working with the data.
Right. So I think I saw somewhere it's something like 40,000 currently, and then there's an extra 35,000.
I think
coming online.
I think if I've got it right, it's 37 at the moment, and we want to get up to. We think we'll need 70,000 people in the future.
Wow. So lots of new, so doubling almost, pretty much.
Yeah.
Well, okay. So how many missions have you been a part of? That's from Henry.
Oh boy, that's a difficult one. So on count these. I did Soho, I did Cluster, I did Cassini-Huygens, I did ISO, I've done FIRST, that's Herschel, Planck, Lisa Pathfinder, XMM, Swift, now on ExoMars, and there's a couple I've missed. So that's at least 10. Oh, Rosetta, 11.
Yep.
So probably getting up to 15.
Wow. I won't ask you to pick your favourite. The ones that didn't blow up mostly, I suspect. With this latest mission, is the science being driven by the thought that Mars was a similar environment to Earth, and to see how the aging of the sun has impacted possible life, with a view of how global warming will impact the Earth? So is there a link there?
Yeah, well, you could consider Mars as a failed planet as far as life is concerned. 4 billion years ago, it was very similar to Earth. You had large areas of water, and 4 billion years ago was about the time when life started on Earth. So feasibly, life could have started on Mars, but it's unlikely to be there now. There's a faint possibility that it could be there, but looking back 3.5 billion years ago, there's a strong possibility. So understanding if life started on Mars gives us an idea of how ubiquitous life could be in the universe. So if it started in 2 planets in our solar system, then thinking about it, of all the solar systems that we now know, there's billions of solar systems. So out there is going to be life at several forms of development. If there isn't life on Mars, then life is even more special, and the Earth is more special. So that's one thing. Understanding about how much life is out there is one thing. The other thing, that now Mars hasn't got an environment that's really friendly to life. It's got severe temperatures. It's not got very much atmosphere. the water is in ice form, and there's a very harsh radiation environment. It now hasn't got a magnetic field like the Earth has, and the Earth's magnetic field protects us from the sun's radiation. So without that magnetic field, the atmosphere is being stripped away. So as the Earth's core cools, will we lose our magnetic field and this protective shield? So Mars could be indicating what the Earth might be like in the future. A very, very long way. I'm not going to worry.
Okay. And I shouldn't start building a habitat now. You don't think? Okay, good. That's reassuring at least. So on the Perseverance itself, someone's asking, how will the rover adjust to the altitude? Not sure I understand. Well, I might have to ask you to clarify that question. Actually, I'll ask you to clarify that question, because the altitude's kind of not really the issue. How will it? I think that one of the questions is, how does the rover cope with the situation it's in? And I think as well that the helicopter, which is kind of new, we've seen rovers before, but the little drone is kind of cool. How's that going to cope?
The helicopter is really a technology demonstrator. We've never had anything flying on Mars. It has a very thin atmosphere. So at the moment, it's carried on the belly of the rover. The rover will drop it off and move a safe distance away, because you don't want to, if something goes wrong, you don't want to damage your rover. And then it will try and take off. It's got solar panels to power it. I think it can take off for about 30 seconds. This was done it's called Ingenuity, and that is really a good name for it. And the thoughts are you can then use a helicopter to scout ahead. But really for this mission, the helicopter is the technology demonstrator. And it'd be really interesting what happens.
Yeah, so that makes a lot of sense. So you might get some value out of it for the mission itself and for the rover, but mostly the number one priority is just, will a helicopter work?
Will the helicopter work? How will it fly? Did it manage to safely land?
So how do you test all this stuff? So there's a question from some of the audience. There must be lots of modeling that's gone on, but how do you trial and test in preparation?
All right, it's quite difficult. You've got vacuum chambers where you've got a partial vacuum, so you can get the atmosphere lower and resembling Mars. And you've even got some chambers that will work with dust inside them, so you can test them in there. But you can't. It's very difficult to test for the lower gravity. So Mars's gravity, I think, is about a third. It's about 2/3 of Earth. So testing it in that lower gravity is things in the lower gravity is really difficult. So when you actually see test rovers, they'll take a lot of the weight off to make representative. So you'll basically get a chassis rather than the full rover, so that the mass of the rover is roughly similar to the full rover when it's on Mars. So that's one way they do. Another way is on using you can sometimes use parabolic flights. This is where you go in an aircraft and it does a parabolic flight, and at that top curve you get about 30-40 seconds of zero G.
Is this the vomit comet?
The vomit comet, yeah.
Named for obvious reasons.
Named for obvious reasons. And there are ways of setting up experiments so that in different areas of the curve, you've got different levels of gravity. So you could have a few seconds of a gravity like Mars. There's limited numbers at times you can test that. You do a lot of thermal tests. So you cycle the equipment round, heating up to temperatures and to lower temperatures. Um, I'm working on a mission, another rover mission called ExoMars, which will go in 2 years' time. So we are testing the electronics at a minus 120 degrees, because that's the sort of nighttime temperatures you get. And you will cycle it round Mars. Your temperature on a really hot day, you'll get up to 20 degrees. So having your equipment working through that thermal range is really important. Going back to the vomit comet, I have done a vomit comet. It's great. I would recommend it to anyone.
And did you?
No, I followed the instructions. I took the maximum you are allowed in sort of seasick pills. And the advice is, when it's transitioning between zero gravity and full gravity, keep absolutely still and keep your head still. And I was fine. We had some experiments. People were doing experiments to do with astronauts, and they were jumping up and down on a step box during those transitions, and every single one of them was sick. And
not while you were floating around together in zero G, hopefully.
They started to feel sick, and were moved away to sick up in the sick bags. I've never seen anyone look so pale in my life.
So I'm gonna lump a few questions together here, because we've got some on a couple of different themes. One is, I mean, it goes back to what you're saying about life, really, and so they're saying, what exactly are you expecting to find? Is it life, and what sort of life is it likely to be? And then I think it links to another thing that you mentioned, the ExoMars. So a couple of people asked, what's next? What mission are you working on next? So I don't know if those two are linked, but
yes, they are. Right. Life on Mars 3.5 billion years ago, if it was there, will have been microbes. If it's there now, again, it will be microbes. I think we've found that life can survive in more extreme environments than we thought. So you do get microbes in the Antarctic, in really cold places. They have found microbes several kilometers underground in mines, when they've been in mines. So the life can actually survive really extreme environments. It grows very slowly, but it is possible. Now, ExoMars is looking for exobiology. It's designed to look at the geology. It has a drill that goes 2 meters down, and therefore it will go below the shallow surface, which is affected by the radiation environment. So that gives you the best possible chance of finding life. It has a suite of instruments around life, finding organic compounds, and working out if those organic compounds are from life or sort of naturally forming organic compounds. That should have been launched at the same time as Perseverance, but we had problems on the testing campaign, and then COVID, and we couldn't get sufficient tests in to be confident in landing, and therefore we took the decision to postpone for 2 years to allow us to do those tests.
And 2 years is that next window when
that's the next window. So it will launch in, I think it's the end of September 2022, and get there about February.
Okay. And what's that one called? What's the rover called?
It's ExoMars. The rover is called Rosalind Franklin. We held a competition a couple of years ago, and it's been named Rosalind Franklin.
After the scientist.
After the scientist, yeah.
Yeah. I've got a couple more questions then. So here's a bit of a left field one for you here. So is the UK Space Agency involved with Elon Musk and SpaceX and Tesla? Why not throw that in? And how can we get them involved in Swindon, UK for Mars human exploration? Does Elon pop over to the office?
No, he doesn't pop over to the office. We have had their salespeople. We've had several talk with them about the cost of understanding the cost of an astronaut, understanding whether we might use them for provision of launch for experiments. At the moment, our exploration program is the majority of it is through participation in the European Space Agency. And through the European Space Agency, we have access to put experiments on the International Space Station, the Vomit Comet, drop towers, and our work on lunar experiments. So at the moment, we're working with ESA, but we have to look at the costs and see what the benefits are. So we have had discussions with SpaceX to see what their costs and how it compares with ESA. The advantage of working with ESA is the work comes back. We pay a subscription, and they put work into the countries to reflect the amount of money you put into ESA. So the money comes back into the UK as contracts into industry. So working through ESA means that we develop our industrial capabilities. If we just buy a commercial service, then we're not doing that. But it might work cheaper to do that for some things.
Yeah. Okay. And presumably we're pitching to try and do the cool stuff when we get the money back. Is that how it's defined? The cooler stuff.
The cooler stuff. That is one way of defining it. What I'm looking for on the industrial technology, one is just pushing the technology. One is developing unique capabilities. The other thing you're looking at is what is the potential for spin out? Will this technology feed into the commercial space sector? Does it have a high potential for spin out? So one of the reasons we went into developing rovers, so ExoMars Rosalind Franklin has been built at Stevenage by Airbus, was that they need a high level of autonomy. And that knowledge of autonomy, you can't go up there and tweak things. You have limited periods to communicate with your rover. So you want it to do as much as possible without human intervention. And we thought at that stage that there was going to be a lot of autonomy in the future, and so there was high potential for spin out. However, working with space, you never know where the spin out is going to be. So whatever you do, you're likely to get a spin out. So we have worked on a control system for an acoustic drill. That is now being used in a welding process for aluminium tin cans, and has reduced the amount of aluminium you need in a tin to produce a tin can by 10%. So although we're doing cool space stuff, it actually brings technology that's being used back on Earth.
You're saying I'll be eating beans out of space-age tin cans?
Yes.
Essentially. Good. I think it'll make a difference to me. But I mean, it's a big deal in terms of the saving of resources, actually, when you're doing that, kind of taking that off. So it does make sense. I've got a question around, and I think you just touched on it there, the sending the instructions to first the rover, but then also the helicopter as well, because you can't remote control them, can you?
No, there's 11 minutes to take a signal to go from Mars to Earth at the moment. It can be as bad as 20 minutes and as good as 6 minutes. So there's no way you could joystick control it. It has to be autonomous. And at the moment, when you're on the surface and sending the signal, it goes to one of the orbiters and then is transferred to Earth. You only get a couple of contact times per day.
Okay. So you can only send the actual instructions a couple of times.
Yeah.
And does that include your opportunities to receive information back?
Yeah. So that's why basically the scientists tend to work Mars days. Is at the end of the day, you'll get an image. You have to work through from that image what you're going to do next, and have a plan ready to be uploaded at the next period where you can transmit. Okay.
That's yeah, it's just a lot of planning. It's just a lot of planning, isn't it? So I think we are going to have to close. We're going to run out of time. I think there are just endless questions coming through. Can I just we're going to be back on the program again at 5. We've got the European Space Agency and a panel of researchers from across the UK again who work with satellites to study aspects of climate change, and they've got some amazing imagery from satellites there. And then later on, we've got the Never Explained Science Comedy panel. So do people come back for that? But I just want to thank you, Sue, for actually you've had a horrendously long week and stressful week. And so to take some of your weekend to come and talk to us is incredibly generous of you. So I do really appreciate it. Thank you very much for that.
Right. It's been a pleasure. Thanks.
Thank you. Really good to speak to you again, Sue. And enjoy the rest of your weekend. Thank you.
Great. Thank you.